I'm Dave Hammer, an amateur blacksmith with a little experience I'd like to share with you. This video is going to show you how to build a simple, naturally aspirated, atmospheric propane burner. This burner is not an original idea of mine. I was first made aware of this basic design by a friend of mine who lives in northern Minnesota. He has a burner that a Canadian blacksmith had made. Last year at a national blacksmith conference, one of the demonstrators was using this type of burner in his forge. He told the audience that he makes his own burners and passed around a sample burner for us to look at, giving us enough information to make them for ourselves. Another friend of mine is fabricating a burner of similar design and selling them. All these burners are similar in that they use a length of pipe with drilled holes for aspiration and an orifice feeding the propane from the end. The physical orifice and how it is held in place varies across the burners I have mentioned. This video shows you my version of how this burner is made and how the Orifice Assembly is put together. For those of you that are interested in this type of burner and would rather not make one yourself, I recommend you purchase one that is commercially available. However, if you are handy with basic tools, have a drill press, belt sander, and a few other hand tools, you can easily make this version of the burner for just a few dollars. This burner, if used as I described in the video, will heat a properly insulated small propane forge to welding heat. During this video, you will see and learn how I build these burners as well as how I manage the use of propane. The parts used to build the burner are as illustrated by this photo. Starting at the upper left is a 9-inch length of 3/4 inch Schedule 40 iron pipe. This pipe will become the body of the burner. Next to it is a 3-inch length of stainless steel pipe that will function as a flare on the end of the pipe. The flare slides over the iron pipe and is held in place with a set screw. The second row shows the parts used to make the Orifice Assembly. It consists of a 1/4 inch pipe street elbow, a 1/4 inch pipe coupler, a brass fitting that has 1/4 inch pipe thread on one side and a flare fitting on the other, and lastly a .025 MIG tip. The third row has a male quick connect fitting, which I will discuss more later in the video. All these parts, with the exception of the stainless steel pipe, can be purchased over the counter at hardware, plumbing supply, welding supply, and hydraulic supply stores. If you are lucky, you may find them all at a single store. Good luck with that. For the iron pipe, if you don't already have some, I recommend buying a 12-inch nipple and cutting off the threaded ends. The quick connect fittings I use are Parker hydraulic parts. Quick connects sold for use with air systems should not be used because their O-rings are not propane gas friendly. Not good. This photo illustrates the progression of building the burner. The bottom row has all the parts needed to assemble the burner, with the exception of a missing set screw for the flare. The middle row shows the Orifice Assembly put together, the burner body with the aspiration holes drilled, and a forged flare. A complete assembled burner is shown at the top. The flare needs to be forged to have a taper, about half the length of the pipe, before assembly. Although I make my own flares, some of you may choose to purchase a commercially available flare rather than forge your own. They are available online from a number of sources. If you choose to make your own, you will need to find a source for the short piece of stainless steel pipe. This pipe is not usually available at the types of stores I mentioned earlier. You may find it online at steel suppliers or, as I do, at steel recycling centers. For those of you that want to make your own flare, a more detailed discussion about them follows with the next illustration. If you want to make your own flares, you will need a drift as shown. I believe the recommended angle of the flare is 12 degrees, but I have used the illustrated drift and others with acceptable results. I have not measured the number of degrees of flare that this drift produces. The stainless pipe needs to be heated to a yellow heat, then the drift driven to form a taper over about half the length of the pipe, maybe a little less. It is important that the drift be driven straight into the pipe. It is also important that you do not damage the ends of the flare when you remove the drift. A set screw is generally used to hold the flare onto the burner body. Put this set screw about 3/4 of an inch from the top. Where the holes will be drilled into the burner body. I use a permanent black marker to mark the end of the pipe, dividing it equally into 4 sections. I then draw a line down the pipe about 3 inches from each of those marks. After that, I draw another line down the pipe between those 4 lines, giving me 8 lines in total, equal distance apart. I just freehand drawn these lines. It's important they be fairly straight down the pipe. You may want to do some measuring and use a ruler to make your lines if you're not satisfied with freehand drawing. Next, I use a ruler to mark the position the holes will be drilled. There needs to be 2 sets of holes, the first of which will be centered 2 inches from the end of the pipe. Use the ruler to mark every other line at 2 inches. The second set of holes will be centered at 2 3/4 inches from the end of the pipe. Measure and mark the other 4 lines at 2 3/4 inches with the black marker. Those 8 marks identify where the aspiration holes will be drilled. Use a center punch at each mark in preparation for drilling the holes. I use a 2-step process when drilling the holes in the pipe. First, all holes are drilled with a 1/4 inch drill bit. I hold the pipe by hand. If you're not comfortable doing this, use a drill press vise. Be sure that the drill bits are sharp. If they're not, they'll create large burrs on the inside of the pipe. It's also safer. First, all the holes at the 2-inch marks. And then the 4 holes at the 2 3/4 inch marks. I've replaced the drill bit with a 1/2 inch drill bit and go through all those holes again, holding again by hand, but you may want to use a vise here. A large drill bit grabs. And again, it's important that the drill bit be sharp. All holes done. There will be burrs on the inside, so I use a rat tail file to clean as much of that out as I can. Just a round file in from each end, being sure to scrape the entire inside surface of that pipe. There may be some burrs that are hanging on to the holes that that are in the holes. So I use a small file to go in and take all those out. It's important that all these burrs be removed. If you have a Dremel tool, it could be done a little quicker. Next, it's back to the drill press to drill the hole for the set screw that's going to hold in the Orifice burner assembly. Then to the vise to tap that hole. I use 1/4 by 20 set screws. A set screw at 1/8 or 3/16 of an inch long is long enough. Clean the burrs on that one. This next step is not necessary if you have a clean pipe, but I like to polish it up a little bit. So I just go to a slack part of my belt sander and sand off the rust. Polish it up a little bit. If your pipe is painted, you certainly want to do this because these burners do get warm, and if you don't, you'll be burning paint off. And it's kind of smelly. Camphor the ends a little bit. Next, we are going to put together the Orifice Assembly. If you recall, these are the parts that make up that assembly. The quick connect is not shown here. If we just put these parts together as they are now shown, the assembly would not fit into the burner body. The 1/4 inch pipe coupler needs to be modified so that it will slide into the burner body. We will reduce the outside diameter of the coupler using a belt sander. After that, the next step will be to cut the flare side of the brass fitting off and use a tap to thread the inside of the remainder of that fitting so the MIG tip can be screwed into it. Let's go. These next few steps are working on the Orifice assembly. First of all, check to see about how much it looks like you need to slim down the coupler. Put 2 short lengths of 1/4 inch pipe into the ends of the coupler and then go to the belt sander. This is kind of my version of a poor man's metal lathe. If you're a machinist and you have a lathe, you could obviously do this on your lathe, but this actually works pretty good. Go slowly, check to see if it fits occasionally. Go a little bit at a time. You do not want this loose in there. If it's loose, your orifice will not align properly with the burner tube. Back to checking. Go just a little bit at a time, very light touches. This time it went in. Next we'll take the little brass fitting and we'll cut the flare end off. The only reason to do this is to make it shorter. The end of this is going to be tapped for the MIG tip. Most MIG tips are one of 2 thread patterns, 1/4 by 20 or 1/4 by 28. You have to look at your MIG tip and see what you have and get the appropriate bit and tap. These I'm using happen to be 1/4 by 20, so I can use the same tap I used for the other set screws. Tap that out. Check again that it fits. Take those pieces of pipe off. Now, when you're sanding this, it's going to heat. It's going to get hot, so be careful you don't burn yourself when you're working with it. If I was a safety nut, I'd be wearing gloves when I was working on that sander. Something I didn't do here was use a sealant when I put this together for the video. I did put the sealant on later, but it's important that you do use a sealant because this assembly actually ends up being a little chamber in there that is holding propane and then spitting it out. And you don't want any leaks in that, so use a sealant, a good sealant. Don't really recommend tape, but I have used it. A good Loctite sealant is best. Love water pump pliers. Putting this thing together with the sealant, make sure everything is tight. You don't want this falling apart during its use. There's our Orifice Assembly. Fitted in the burner tube. Put the end of the tip in the center of the bottom holes. Add the set screw to lock it in place. Tighten that up. Next, the flare. We're going to put the flare on in an approximate position about halfway. This will be adjusted later to produce the best flame. The next step is to put the quick connect on the end of the Orifice assembly. Again, be sure that you use a sealant. It's important. This is actually a little chamber in here that you don't want leaking. After this is on, we'll clamp the burner. It's essentially finished. It needs to be tuned, but it's essentially finished. Clamp it into a vise, hook it up to a propane source, and fire it up and see how it works. I use a little propane torch to light it, estimate the pressure at around 15 pounds or so. And then I'm looking at the flame. What I'm looking for is a nice color blue flame, and for it to hold at a nice blue at different pressures. I'm playing with a needle valve there. It went out because I turned the needle valve too far, and then I lit it again there. So the flame isn't bad, but it can be better. And to get it better, I'm going to loosen that flare with an Allen wrench and just move it a little bit till I get the most pure looking blue flame. It's hard to tell in this picture how much improvement that was made, but it was significant. So I'm just moving that flare up and down a little bit, then tightening it up again. Next, we put it in a forge. We'll put the tip of the burner, tip of the flare about an inch above the ceiling of the forge. Okay, and tie that burner in. I also use a little bit of thermal blanket to seal around the flare so that that pipe doesn't become a chimney. Hook up the propane source and light. I throw a match in as I turn the gas on. In just a few minutes I have this. This is the result. This is the first time that burner that we just built was fired in a forge, and within a few minutes I've got yellow hot steel I can forge. This graphic shows the entire propane hose and fixture chain from the regulator all the way to the burner tip. And I'll talk about each of these and why I chose them and where I bought them. I use a regulator that I purchased at Tractor Supply Company. It's a Mr. Heater regulator. I don't have the box that came in to show you that, but it's Mr. Heater. Pressure 0 to 60 psi, and I literally crank this thing all the way up. I manage the amount of propane that goes into the forge with a needle valve, which I'll talk about a little later. Some folks I know don't even use a regulator. They just hook the hose directly up to the tank. I'd rather not do that because if something does happen with the hose, I'd rather be just dealing with 60 pounds or less of pressure than the 100 or 200, whatever there is at that tank. I like to use stainless steel braided propane hose, and this is just a safety issue with me, so that if you pull a hot piece of steel out and you brush it against the hose for some reason, you're not melting that hose. Although I think a good rubber outside hose has a liner in it that would protect fairly well, and I used those for years. But this stainless steel braiding I like. Be sure it's a high pressure hose. This one I bought on eBay. I'm sure there's other places, propane supply houses, where you could get this. These are pricey, but I think they're worth it. Also, this particular hose didn't have the proper fittings on the end, so I had to buy adapters to fit my 1/4 inch pipe thread. It's just a little 1/4 inch shutoff valve. Be sure that what you buy is rated for gas usage. They are not all rated for gas usage. This can be bought at any hardware store. I probably bought these at Home Depot or Lowe's. As I mentioned earlier, I use a needle valve to control the volume of propane that goes into the forge. I just crank up the regulator all the way, and I use the needle valve. If you have a gauge on the right side of this, you can see the pressure that's going into the forge. I basically never use a gauge on my regulators anymore. It's important to have a very good needle valve. Cheaper ones will fail somewhere down the line. I've never had one of these fail. I've been using them for like 15 years. They can be bought probably numerous sources. Industrial Supply. I order mine from Price Engineering. It's a firm in Wisconsin. Their phone number is listed there. I'm sure there's lots of good brands out there also other than this one. I just know that this one's reliable. The quick connects I use are actually hydraulic hardware. These are Parker hydraulic units. You can find these online or buy them at a hydraulic hose store. The product numbers are BST-2 and BST-NM2. They have other male or female fittings also. The MIG tips I use are those as shown. They probably wouldn't have to look exactly like this. The taper is better, I think, a little bit, but it's not significant, and you can buy these in numerous places, certainly at welding supply stores. I use this gauge in the hose line more as a curiosity than a necessity. I occasionally get asked how much pressure I'm running, and up until recently I didn't use a gauge, at least not for a long time, and I put this in just to see at what pressures I was running. I control the amount of pressure with that goes into the burner with the needle valve. The pressure back at the tank is, as I said before, cranked way up. So in general, I'll run a forge as much as 30 psi, and after it gets hot, I'll back it down. But I've always done that based on the sound in the sight, not on a pressure gauge. But if you want to be consistent, then having a pressure gauge is probably a good idea. I made this one this way so I could use it in different venues, different things I play with. You can buy this pressure gauge at a welding supply store or wherever. They can be bought in almost anywhere. Finally, this is the thread sealant that I use. This is a new tube, but and I'm no expert in this stuff. I just know that some engineers and safety people that I think very highly of recommend this particular sealant. Lots of folks use Teflon tape, but I've been told and read many times that Teflon tape can cause problems when you have these small orifices. So anyway, this is what I buy. This is pricey, and I'm not saying it's the only thing you should use. You have to decide. This tube retails probably for about $20. I buy it at a hydraulic supply store for about $15, and it's well worth it. This is a lot. This is 1.7 ounces almost, and it'll last for years. So that's it. One more thing. I'm going to talk just a second about the propane forge I use. This is my most used propane forge. It's just a small one. It's 8 inches long and 8 inches outside diameter. It's just it's an 8-inch slice of a large oxygen tank. The channel iron that's on there that holds the doors are just a standard 3-inch channel. In the future, I intend to produce another video where I show how I build this, although it's looking at it, it's fairly obvious, but how I build it and how I line it, and the materials I use. I hope this information has been useful. I appreciate your interest. Thanks for watching.